So, my name is Yonatan Goldschmidt. Today we are going to talk about performance, optimization, and what's in between them. Let's start a bit by talking about me. Most of my experience came from 6 years in the IDF. I served as an R&D specialist and a team lead. I like everything about computers, software, and some wine, as you can see. And today I'm a team lead at Granulate's performance research department. Granulate, in short, enables companies to optimize their workloads, to reduce costs, and improve SLA. We do performance in general. Okay, so let's start with a broad question. Why should I optimize my code, my application? I actually gave those two reasons in the previous slide, in short, but the main ones, practical ones, are to reduce cost and improve SLA. We pay for the resources that we use. If we can get our workload to run on fewer resources, we can pay less to AWS or GCP or whomever we pay. Also, our users get better SLA. Think of any project that you've used, I know, Jira, ClickUp, Google. If the search latency was better, you would love it more as users. So it's something that your users want. And what does profiling come into the picture? Pretty sure most of you have seen this sentence before. We humans are not good at reading code and figuring out where are the bottlenecks. We're just not good at it. We need the help of tools like profilers to guide us, to help us finding what should we look at and what should we optimize. Good things. So what are profilers? Those are the tools that help us to find optimization opportunities, but they help us in other ways as well. And there are many profilers, profiling types available. CPU profiling, which help us pinpoint the CPU heavy code. Memory profilers, which help us find what's taking our memory in the machine. Networking, I/O, locks, disk, many types, and many tools. This is just, I don't know, a third of the Wikipedia page for profilers. There are tons of tools available. Now, profiling is very cool, but we feel like it's not common enough. So let me ask you to raise your hands if you have ever used any type of profiler. Okay, I see some hands. And now let's take it further. If you have ever used any type of profiler in production. Okay, I do see some hands. I hope that after this talk, within 2 weeks or so, I will see more hands if I ever do this talk again. Okay, so in this talk, we are going to focus on CPU profiling, which revolves about the CPU time or the time your application spends on the CPU. If we have a web server that serves requests that take, let's say, 1 second, and of this 1 second, most of the time is spent waiting on some DB requests, and 50 milliseconds actually do compute, CPU profiling will show us this compute time. Only this compute time, not the time that we wait on other resources, for example. CPU profiling is very easy to apply. It has very low overhead because it's sampling based and not tracing based or any other mechanism. And it can give very impactful conclusions on how you can improve your application. That's why it's a very common type of profiling. And I suggest the type that you should start with if you are trying profilers for the first time. So how do we read profiling data? One common way is flame graphs. I suppose some of you have heard of them. Flame graphs, put simply, are a way to visualize stack traces. I have here, which I hope you can read it. This is a flame graph of MySQL. The x-axis shows the number of samples for a given stack trace. For example, if we profile for 1 hour and we have 1,000 samples from application, the wider the stack trace is, the more samples it has relative to other parts of the profile. So basically, the more wider a rectangle is, the more interesting it is for us to look at it. The y-axis is a stack trace of called functions. So in this MySQL case, we have, I don't think anyone is seeing, but we have a function called indexPrev, which calls into general fetch, which calls into row search for MySQL. Just your code, basically. Flame graphs are very common tool online. There are many resources which I encourage you to read if you intend to look into profiling. Let's see now a simple demo. I hope you can read this code even in the back. We have here 3 simple functions and a small snippet that calls them in a loop. Those functions are one which sums 1,000 numbers in Python, another one sums 10,000 numbers, and the last one sleeps for 1 second. Now, you don't need to be a performance engineer to know that the last one takes the most time, because sleeping 1 second takes 1 second, and summing 1,000 or 10,000 numbers in Python takes a fraction of a second. But yet, if we look at the profile result, we can see that the sleeper is not visible at all. And why? Because it's CPU profiling. So the sleep time is not accounted into the profile, only the time that the code spends doing compute. Now, what we do see in the top profile is that the ratio between the 10,000 and the 1,000 is roughly 10, because one takes 10 times more than the latter, because summing numbers scales linearly with how many numbers you're summing. This shows us that reading CPU profiles is fairly easy, because you know that if you're looking at 20% and you manage to improve this part, optimize this part, you are also improving by 20% the CPU utilization of your servers. So it's very obvious what you're going to get if you work on something. Okay. So profiling is cool. And now the question is, can I use it on my machine, or do I need to do it in production? So just like I said, we're humans not very good at statically reading code and figuring out what are the bottlenecks. We're also not good at predicting production load. I write my code, I think of 1, 2, 3, 4, 5 inputs, I try my code with them, tests pass, I say okay, and in production, my code experiences something completely different. It gets different load, it behaves differently. So if I profile it on my machine, I can say that it works, but the profiling results I get won't guide me towards optimizations that will help in production. Code will run better on my machine, my tests will run faster, but it won't help in production. Additionally, it's important to profile continuously. Most applications have varying load over time. For example, let's take this one, which I sort of modeled after Walt. This is the load, let's say, in some units, and the time of the day. And at some point in lunch, people order their vitrina, and the load goes high. People also order dinner, so load goes high at dinner. And at some point in the night, people are hungry, and they get the nut cookie. But the load is not the same. If I profile my Walt backend at, I don't know, 4 p.m., and I profile it at 12 p.m., it's going to be completely different. We need to profile continuously. Also, we make many code changes. We make many deployments per day. We want to always have the full picture of what's currently running in our application. So if I profile it once and then someone deploys a new version, then it eliminates the code or functions that I had previously looked at in my profiles. I'll just be optimizing something wrong. We need to look at the current live picture of what's happening in production. So let's wrap it up to some practice of how this basic profiling circle looks like. We continuously profile our application. We analyze the results. We implement the improvements, test them, deploy them, and we verify the results in the next profiles, I don't know, a few hours later. And we repeat that. And at the end, we have a 0 cloud bill. Not kidding. Okay, now it's time for a demo, if the demo gods will be with me. What I have here is a demo of a simple Flask application, and I've profiled it with gProfiler, which is our free open source system-wide profiler, which works with many different runtimes. I'm going to present Python, but it works with Java and Node.js, Ruby, and others as well. So now I will switch to the demo. Here I have this server. It is running this Flask application. You can see that it uses 4 cores, which are utilized at about 80%. Now I'm going to run the profiler itself. It's basically just a bash script. The profiler itself, I'll show you by cutting it. It's just a simple Docker container that you run on the machine. It can also be a daemon set or an executable that you run on a server. Let me start it. Okay, it has started. Now, it will take a few minutes to actually collect profiles, and we don't have a few minutes, so I have prepared the profiles from before. And we will look at the profile, but first let's take a look at the application code itself. I will give you a few seconds to look at it and think what may be the main CPU consuming line or issue here. Let me give you a few more seconds. It's a very simple Flask application. You access it on Slash and it downloads a random picture and gives it to your browser. Really does nothing. Anyone has any idea? SSL, what about it? Expensive, yeah, but well, I want to download an HTTPS URL, so I have to do my SSL. Which part of the SSL? The handshake. Maybe. Okay, we'll see soon. Any other ideas? Okay, let's take a look at the profile. So, this doesn't work when enlarged. Anyway, we have the profile here of the G unicorn. Let's focus on it. We have the Python stack trace, and we have some purple code. Purple code is native. So it's native code that our Python calls into. Basically, the main function here is download the image. I'm not sure if you're actually able to see the font. Believe me, it's download the image. And we can see that it calls into some Python code, which is the actual download. So if you thought it was the handshake, it's not the handshake, because the handshake would be somewhere in this area, which is the download itself. Now, on this left, we have this huge purple thing, which is not obvious, because if we take another look at the code, all this function does is download the URL. So if the URL is this side, what's this thing? So this is a function from OpenSSL called x509 store load locations. What's causing it from Python is this line, which was very innocent, and nobody here told me that it might be the problem. This function reads a file which is a list of certificate authorities. You don't have to use it when using SSL in Python, because Python has a default SSL context. Some libraries and frameworks like to use their own CA files because they want to use only specific CAs. For example, Botocore, the AWS library, does it. So they have to create their own context and to read this file. And if we look at the profile, we see that my app spends 70% of the time reading certificate files and parsing them just to throw the context away. Now, the thing is that you don't have to throw the context away. You just have to think that its creation is something expensive and take the code, move it here, and this completely solves the issue. Now, let's run the fixed application on the server. Stopping this one. Stop. Running the good one. And starting the low. You can now see it's also running requests faster, but I don't have the throughput here. But we can see that the CPU is much slower now. Much, much slower. I've cut its CPU by about 50, 60%. We can also take a look at the fixed profile and see that now this purple part is completely gone. All I'm left with is the actual download of the image, the actual SSL. Here we can see the handshake, by the way, somewhere here below. This is the handshake, those two purple parts. So let's get back to the presentation. I hope this gave you a taste of what profiling may be like. Now, this was a real find. You don't usually find 60% reduction with a minute of profiling, but who knows? You have to try. Now I'll give a more conservative example. We are using gProfiler on our production systems regularly, and I have a small example of using it on our server. This is a profile from one of our applications. I'm reading it regularly once per week, once per few days, and I saw this function called remove handler f. It's something from Python's standard logging library. I'm sure all of you use logging, so all of you also use this function. You just don't know. And it was taking about 3% of my profile, which seemed too much for me. I looked at its code. This is the code from Python 3.9. This function really does nothing. It's taking some lock, removing a handler object from a list of handlers, and releasing a lock. What may be the performance issue or bottleneck here? Any idea? It really does nothing. The locks maybe, yeah, but lots of indexes, and if they're not taken, the acquiring of them is very, very cheap in Python. Sorry? No, try finally is free in Python. Almost free. What's taking time here is that we're doing two lookups for the handlers list. The first if line checks if WR is in handlers, and it may be true. Then the remove line tries again to look through the list. In Python, removal and the in operator are linear. They just search for the list. In our case, the handlers list was very, very long, like 40,000 objects or 50,000 objects, and this function was called very frequently. So this was actually a performance issue. Now, how can we fix the code to alleviate that? An idea? We can do the lookup just once and catch the value error and ignore it because we don't care. Now, this is a patch I actually sent to CPython, and it got accepted to Python 3.10. So all of you have your logging a bit faster, thanks to it, just a bit. In our case, it was amazing. It was I don't know, about 2% of our server was this stupid function. It was something, but it benefited the world. That's it. Okay. So I have two takeaways for you from this presentation. One is that profiling is an iterative process. Most of you won't find this 50% store load locations function in your site. You will see 1-2% function like this one, then another 1% that you can optimize, another 3%, another 5%. You may think it's not enough, it's not much. I spend time optimizing just 1% of my application. But those percents add up. And eventually, this 1, 2, 1, half, 1, 5, they make up your cloud bill. So do it iteratively, and with time, you will see how your application uses much less CPU. Another thing is that you may think that you know your code. I have a story about myself. I said I was 6 years in the IDF. I worked mainly on one project. I've written, designed, tested, debugged, read, reviewed many areas of its code, and I thought I know it best. And the first time we came about thinking about performance, I remember we profiled the code. I looked at the profile and I was like, what the hell? Functions that I prematurely optimizing and thinking that they take most of the time turned out to take 0 of the profile. Other functions which I looked at and said, nah, it's nothing, no chance it's of any relevance, turned out to take 40% of my profile. With just a few days of work, I was able to cut 40 or 30% of this project. It was amazing, and I thought I knew, but I didn't know. So unless you profile, you just don't know what's waiting for you. Thank you. And you can try free profiling.